example which is based on the consistency of the system of linear equation. The question is examine for consistency, and if consistent, then solve the following system of equations. So there are three equations: 2x minus y minus z equal to 2, x plus 2y plus z equal to 2, 4x minus 7y minus 5z is equal to 2. So we have to check that this system is consistent or not. And this is the first question. And the second question, if the system is consistent, then we have to opt in the solution of the given system of linear equations. So let us try to solve these equations. So we have to examine the consistency of the following system of equations: 2x minus y minus z equal to 2, x plus 2y plus z equal to 2, 4x minus 7y minus 5z is equal to 2. Let me give it equation number 1. This system of simultaneous equations 1 can be written as ax is equal to b, where what is a? A is nothing but the coefficient matrix, coefficient of all the variables, like that 2, minus 1 is the first row. Similarly, 1, 2, and 1 is the second row, and 4, minus 7, minus 5 is the third row. And the last one is this is the variable x, y, z, variable matrix, and this is the 2, 2, and 2. This is called constant matrix, where A is called coefficient matrix, X is called variable matrix, and B is called constant matrix. Let us consider the augmented matrix, because if you want to solve the given system, or if you want to check that the given system of equation is consistent or not, we have to find out what is the rank of coefficient matrix and augmented matrix. So let us just consider augmented matrix is nothing but the combination of coefficient matrix and constant matrix. So now we want to find out the rank of augmented matrix as well as coefficient matrix. So now we have to first reduce this matrix to its echelon form. So for echelon form, we have to first ask the question, is A1 1? So answer is no. Then again ask the second question, are all the element below A11 are multiple of A11? So clearly the 4 is multiple of 2, but 1 is not multiple of 2. So we are also getting the negative answer of the second question. Since we are getting the negative answer of both the questions, therefore we have to make this 1. A11 1. So how to get it? So let us interchange row number 1 and row number 2. So the reduced matrix is, equivalent matrix is 1, 2, 1, 2. This second row become first row and first row become second row. 2 minus 1 minus 1, 2. 4 minus 7 minus 5, 2. Apply. Now, what is our aim? Next aim is to reduce this within using the A11, which is 1. We have to make this and this 0. So for this purpose, we have to apply in R2, R2 minus 2R1, and in R3, R3 minus 4R1. So what is augmented matrix? Let us check it. This values are correct or not. So the first, let us take the first operation. R2, what is R2? 2 minus 1, minus 1 and 2. And then multiply this by 2. So 2, 4, 2, and 4. Let me subtract it. So 2 minus 2 is 0. Minus 1 minus 4 is minus 5. Minus 1 minus 2 is minus 3. And 2 minus 4 is equal to minus 2. So just look here. 0, minus 5, minus 3, and minus 2. So we opt in the second row. Let us try to find out the third row. So what we can do? What is the third row here? 4, minus 7, minus 5, and 2. Let us multiply the first row by 4. So what will happen? This is 4, 8, 4, 8. Let us again subtract it. This is 0, minus 5 minus 7 minus 8 is minus 15. Minus 5 minus 4 is minus 9. And 2 minus 8 is equal to minus 6. So just look here. 0, minus 15, minus 9, and minus 6. So in this manner, we can apply the row operation and reduce the given matrix into this form, where below A11, these two elements are 0. Now, we go to the step number or second phase of this question. Using A11, we have made all elements below A11 0. So similarly, we go to the A22 and we are able to make this below A22 0. So again, we ask the same question. Is A22 1? No, it is minus 5. So we get the negative answer of the first question. Let us ask the second question. Is below A22 is a multiple of A22? So clearly minus 15 is multiple of minus 5. So we can apply the operation. So what should be the operations? R3 minus 3R2. So we have, there is no change in the first two row, but the last, if we multiply this by 3 and subtract it, so what will happen? 15 minus 15 is 0, minus 9 plus 9 is 0, minus 6 plus 6 is 0. So we have 1, 2, 1, 2, 0 minus 5 minus 3 minus 2, 0, 0, 0, 0. Now, this is an echelon form of the given matrix, right? Because the last row will become 0. So we don't have any A33, which is non-zero. So we have reduced the given matrix because this is what? It is the main diagonal, and below the main diagonal, all elements are 0. So this is an echelon form of the given matrix. Now, let us find out what is the rank of augmented matrix and rank of coefficient matrix. So clearly, the last row is 0, 0, 0. So there are only two non-zero rows, the first two rows. So the rank of augmented matrix is 2. And also, if we consider about the first part, so again we have the two non-zero rows. So the rank of coefficient matrix is also 2. So clearly here, the rank of A, which is equal to rank of augmented matrix, both are same. So therefore, the system of linear equation is consistent, right? But since the number of variable is 3 and the rank of A and augmented matrix, which is 2, which is less than the number of variable, so at that time, we get the infinitely many solutions. Okay, so the given system of equations is consistent and have infinitely many solutions. So now we have to find the solution of 1, which are infinitely many solutions. So let me again use the from equation number 2 and equation number 3. This is equation number 2 and this is equation number 3. So what we have to do? We have to just replace this coefficient matrix by this coefficient matrix, and the constant matrix, this is replaced by 2 minus 2, 0. So the equation can be written as, this 2 can be combined and as written as 1, 2, 1, 0 minus 5 minus 3, and 0, 0, 0. This variable will not change, and 2 minus 2 and 0. Now, let me simplify it. X plus 2y plus z is equal to 2, and minus 5y minus 3z equal to minus 2. So now clearly we have three variables x, y, z, but we have only two equations. It means that the one variable is independent. So let us try to put here the number of variable is 3 and number of equation is 2. So out of three variables, one variable is independent. So let z is equal to t be the independent variable. Then putting the value of z in equation number 5. Now in this equation number 5, we are putting z equal to t. So we have minus 5 minus y, t means minus 5y minus 3z. So z is replaced by t, which is equal to minus 2. So minus 5y is equal to minus 2 plus 3t, because this minus 3t transfer to the right hand side, it will become plus. So what is the value of 5y? So 5y is nothing but 2 minus 3t. And so the value of y is equal to 2 minus 3t upon 5. So this is the value of y. Now, putting the value of y in equation number 4 and z, value of y and z in equation number 4. So what we have, x plus the value of y is 2 minus, this is the value of y, 2 minus 3t upon 5, and z, the value of z is t. So let us simplify it. Let us multiply whole equation by 5. So this is 5x. This 5 will cancel. So 2 times of 2 minus 3t. So 2 2s are 4 minus 60. 4 minus 60. And we multiplied this t by 5 and 2 by also 5. So this is 5t and this is 10. Now if we again simplify it, 5x plus 4 minus 60 plus 5t is equal to 10. So minus 60 plus 5t will become minus t. This 4 goes to right hand side. So 5x minus t. And this 4 goes to right hand side. So 10 minus 4. So 5x minus equal to t plus 6. So what is the value of x? X is nothing but t plus 6 upon 5. Hence the solution of the given system of linear equations is given by x equal to t plus 6 upon 5, y equal to 2 minus 3t upon 5, and z is equal to t. So now why it is called infinitely many solutions? Because the value t has infinitely, t is a real number, and we know that the real number has infinitely many values. So if you put one value of t, we get the one set of answer. Value of t is another value, then we get the another set of. So now when we are substituting the different values of t, we will get the different values of x, y, z. So that's why this is called infinitely many solutions. So thank you, everyone.